It shouldn't exist. In a universe that is only 330 million years old, something like this simply couldn't be there. Not according to physics, not according to the models, not according to everything we've learned about how galaxies are born. And yet, she is. A colossal galaxy, shining with absurd intensity in a cosmos that had barely begun to ignite its first stars. Too big, too old, too complex for that era of the universe. It's like finding an entire skyscraper in the middle of a civilization that has just discovered fire. There was no time to build it. There wasn't enough material to form it. There was no known process that could explain its existence. But it exists. And if that galaxy really is there, then something profound about the birth of the universe might be wrong. The James Webb Space Telescope was launched with a simple mission: to look deeper into space than any instrument had ever managed to. The deeper you look, the further back in time you travel. It's like receiving a letter that took 13 billion years to arrive. What Webb found in those letters was not what he expected. It was disturbing. There were immense galaxies where there couldn't possibly be immense galaxies. Structures so rich in stars, so developed, that astronomers began to call them by the only name that made sense: universe destroyers. That's no exaggeration. That's the real nickname that scientists gave them. Think of it this way. Imagine you're walking through a forest and in the middle of nowhere, you find a 500-year-old tree. But you know for sure that the forest is only 30 years old. The tree shouldn't exist there, yet it's there, rooted, enormous, defying everything you thought you knew about that place. That's exactly what Webb found. But there's an even stranger detail. One of these galaxies, called JD's GS-Z11, wasn't just existing where it shouldn't. It was emitting a very specific type of light called Lyman-alpha radiation, a light that carries the hallmarks of energized hydrogen. And here's the problem. This light should not be able to escape. At that point in the universe, all of space was filled with a dense fog of neutral hydrogen. This fog absorbs exactly that type of radiation. It's like shouting inside a room lined with cotton. No sound comes out, but then the light went out. Not only did she leave, she opened a clear corridor 650,000 light-years wide in all directions. A hole in the primordial mist of the cosmos. Astronomer Joris Wittstock of the University of Cambridge, who led the analysis, said bluntly, "This was completely unexpected." So what's going on? There are two possibilities. Either reionization, the process by which the universe gradually turned on the lights, began much earlier than we thought, or it happened much faster. Either way, our models are wrong. And that's not the only place where they're wrong. There's a tension that was already irritating cosmologists even before Webb. It has a technical name: Hubble tension. Here's the simple version. There's a formula that describes the speed at which the universe is expanding. When scientists calculate this speed based on theoretical physics, they arrive at one number. When they measure it directly using stars, supernovas, and gravitational lenses, they arrive at another number. The two don't go together. And Webb, instead of solving the mystery, confirmed the discrepancy. He deepened it. Theory says one thing, reality says another, and nobody knows why. Some researchers are proposing an answer so radical that 10 years ago, anyone who suggested it would have been met with absolute skepticism. What if our universe wasn't the only one? What if, at the moment the infant universe began to expand, it was being absorbed by a larger cosmos? What if what we call inflation, that overwhelming expansion right after the Big Bang, was actually our universe being pulled in, incorporated, merged into an even larger structure? Mathematicians have created models to test this. The result was surprising. When they calculated the expansion rate using this universe merger scenario, the numbers matched. Not perfectly, but much better than anything we have today. Break. Breathe. Because now things get even stranger. There is a man who isn't waiting for models, who says he already has the evidence. His name is Roger Penrose. He won the Nobel Prize in Physics in 2020. He is one of the most respected living mathematicians in the world. And he believes that the Big Bang was not the beginning of everything. It was just a transition. Penrose's theory is called conformal cyclic cosmology. The name is complicated, but the central idea is almost poetic. The universe expands, continues expanding for billions and billions of years, until all matter decays, all stars fade, all black holes slowly evaporate. In the end, only pure energy remains. No mass, no time. And in this strange state, without scale, without reference, a new universe is born. What we call the Big Bang was actually the final collapse of a previous universe exploding to become our own. Death, rebirth, eternal cycle. But Penrose didn't just stay in theory. He looked for evidence, and he claims he found it. The place he looked at is called the cosmic microwave background. Think of it as the echo of the Big Bang, a gentle radiation that fills the entire universe and carries the marks of how it all began. It's like the fingerprint of the cosmos. Penrose and his team analyzed this echo with extreme care, and they saw something that shouldn't have been there. Circles, subtle rings of slightly different temperature from the surroundings, distributed across the sky, approximately the size of the full moon. He called them Hawking points. The idea behind them is this: in the universe before ours, there were supermassive black holes. At the end of that cosmic cycle, these black holes completely evaporated, releasing energy in all directions, in a process predicted by Stephen Hawking. That energy hasn't disappeared. It crossed the transition to our universe, and the photons, the light particles resulting from this evaporation, were recorded in the cosmic microwave background as circular spots, ghosts of black holes that existed before our Big Bang. Relics of a universe that died so that ours could be born. Not everyone agrees. Many scientists believe that these circles are statistical fluctuations, random patterns that the human brain interprets as shapes because we are wired to find patterns in everything. Penrose responds calmly. Black holes were also called mathematical fantasies for decades. Today they are considered facts of nature. What Webb is telling us, what the impossible galaxies are telling us, what Hubble's tension is telling us, is something that science rarely admits aloud. We don't understand the universe. Not completely. Maybe not even primarily. Each answer we find opens up 3 new questions. And the questions that are opening up now are the biggest that humanity has ever tried to formulate. Was the Big Bang the absolute beginning of everything? Or was it just a gateway? Is there something beyond our observable universe? Something with which we are perhaps already merged? And these circular marks in the echo of the cosmos, these signatures of black holes that existed before everything we know, is it just noise? Or are they the oldest message we will ever receive?